Hi, thank you for joining us today. We're going to talk a little bit about Solidcam. Now, Solidcam is a fully integrated CAM solution for SolidWorks. Today's presentation will focus on multi-channel mill turn and Swiss type machines. With single window integration in SolidWorks, Solidcam is fully associative to the SolidWorks model. At the highest level of integration, we've been gold certified since 2003. This is our interface, and you can see here it's very similar to SolidWorks because it is SolidWorks. We run directly inside the user interface. We simply add our own browser manager here, and you can manage all of your CAM programming right inside SolidWorks on the solid models. With premium CAM functionality, from simple 2-axis through the most complex 5-axis simultaneous toolpath, with unlimited numbers of channels of synchronization and also an unlimited number of independent axes of motion, Solidcam provides the top CAM functionality. Solidcam also provides maximum programming performance with our 64-bit multi-threaded computations, giving you state-of-the-art CAM programming. Now, Solidcam programming is a very visual environment with a lot of plug-and-play and drag-and-drop type functionality, and that's what we want to talk to you about today. Seeing is believing, and being able to see what you're doing while you're programming is very important. We want to show you some of the critical features of our new toolkit and how they relate to advanced mill turn and Swiss type machines, giving you powerful options in Solidcam that are not available elsewhere. So as we open up this local toolkit, you will see that the tool library contains the tools for this project. And we can open the machine preview showing the current configuration of those tools in the tool stations on the machine. As you can see, there are a lot of tool stations available on this type of machine. And in this preview, we can see the existing tools as they would actually be on the machine on your floor. Now, these machines can take very advanced tool holders, and we can manage them through our various tool libraries. Looking at our tool components library, we can see that they can be organized for ease of access. These 3D models of the tool components can be downloaded directly from the website of many manufacturers like these from WTO. Now we're going to drag this 3-spindle face milling and drilling tool directly to the station 32 where we want to use it. And you can see that that automatically updates in the viewport window, giving us true visibility and drag and drop functionality. Now we will add an end mill to this holder by simply dragging it and dropping it on the holder in the tree. You can see that it gets positioned here in this first location. Now by modifying the mounting position, we can determine the exact stick out for this tool. We can also control which mounting point to assign this tool to. So if you want to move it, that's very easy to do also. As you can see here, moving it to joint 2 and to joint 3. We can add additional tools to fill out the rest of the available positions on this holder. For instance, we could add a drill to this holder as well. Now again, drag and drop that drill onto the holder, and the system places it at the first available position. Now we can determine the proper stick out, and we can place the drill in the correct position for this project. Holding on to this theme of advanced visualization, Solidcam makes it very easy to find a tool in the tree by simply right-clicking on that tool in the machine preview and choosing the Select Tool Component option. Solidcam will then highlight that tool in the tree, giving the user quick access to make adjustments to the tool parameters as needed. Another item that we want to talk about today is our machine control operations. These are very powerful features in Solidcam, especially for these complex Swiss type machines. Solidcam gives us premium control over these advanced machines with the ability to move machine components even outside of a toolpath operation with what we call a machine control operation, or MCO. Let's talk about this pickoff MCO that controls how the subspindle grabs the part from the main spindle for the part transfer. Now we can take a look at the parameters of this MCO And again, we can display the machine preview window to help us visualize how to set these parameters and affect the movement of the various machine components. The first parameter controls the rapid approach to prepare for the pickoff. And you can see that this is set for 100 thousandths from the face of the part. Now this next parameter controls the clamp location and allows us to see the clearance from the other tool holders, tools, and of course the guide bushing as well. And we can also manually scroll the movement of this component, and if the component turns red, it indicates that we either exceeded the limits of the component or have a crash with another component. Now again, this gives the user the ultimate visibility and programming control to ensure clean code at the machine. For each machine, we can build out a wide range of MCOs specific to the functions available on that machine. You can see here several MCOs for controlling the main spindle, this section for the sub-spindle, and here are some items like spindle synchronization, superimposition, and C-axis synchronization, as well as part eject, optional block skips, and other miscellaneous options that these advanced machines use. All right, now while we're programming these complex machines, automation can also become a very, very powerful tool to use. So let's talk a little bit about Solidcam's automation for programming performance. Solidcam offers very powerful automation strategies that help you enhance the performance of your programming time while at the same time remaining extremely flexible, allowing you the ability to make enhancements anytime you need to. Now, I'm going to double click on this operation here. And as we look at these operations, now this can be for any type of operation, any technology. Basically what you're going to do is you're going to come down through the operation. You're going to set your geometry, your tool, your levels, technology, functionalities, link-ins, all that kind of stuff to get the operation to run exactly the way you want to use it. Once you've done that with this templates area, you can simply save this off to the templates manager for each of the type of operations that we provide. What I want to do is I want to add a profiling operation down here to the back of this on the sub-spindle. So I'm going to come down to the bottom of the operation tree, and on sub-spindle, I'm going to enter it at this location. I'll open the templates manager, and as we scroll down towards the bottom here, we'll find an area where profiles are, and we have an axial sub-outer profile. This gives us an operation that is similar to this type of a feature on any part that we may have something of this nature. We can simply take this, drag it and drop it here, and the system will automatically create that toolpath on the geometry selected. One of the things that we need is very, very flexible ability to make adjustments. Example here is I see a single lead out, but I need to have a lead in and out. Be better if it was up on top of this arc instead of down inside here for the start point. So I'm simply going to double click on this operation, and in the technology page, go into the geometry modification, and we'll use the shift section. By putting our cursor here, we can simply pick the location on the chain where we want that to happen. Very easy to accept that. Simply recalculate the toolpath. And Solidcam quickly updates the automation strategy to a more specific strategy for this part. Another feature that Solidcam offers for programming advanced mill turn and Swiss type machines that utilize multiple channels is our robust channel synchronization manager. As we open up the channel sync manager, you can see that all of our operations come in as programmed in a very linear fashion, with everything that was programmed on the main spindle side in channel 1, as well as all of the operations on the sub-spindle side in channel 2. Now, to optimize this program, we will want to run many of the operations on channel 2 at the same time as operations on channel 1. Notice in the lower left corner, the estimated machine time is shown based on running the operations in linear fashion. To begin synchronizing these operations, we need to select the first operation on channel 2, and then using this icon on the command bar, we will add a new work piece. This sets the system up to know that there is a workpiece in the sub-spindle as well as in the main spindle, so that we can work on both at the same time. Now, there's no need to define multiple target models or multiple stock models. Solidcam handles this automatically with the Add New Workpiece command. At this point, we can see that the operations on channel 2 have been brought to the top, and additional weight markers have been added, placing them before the channel 1 operations. Now, simply selecting this weight marker and deleting it allows the sub-spindle operations to run in concert with the main spindle operations. Notice that the total machining time has been updated to reflect the synchronization. Now, if we want to add in additional weight markers to cause specific operations to be synchronized, we can just select the operation from channel 1 and the operation from channel 2, and then choose to add the marker above, in between, or below the selected operations. Now, one of the final things I want to talk about today is our advanced machine simulation. Let's take a look at how our machine simulation gives the user the confidence to go straight to the green button. Solidcam's machine simulation is a powerful tool when you're working with Swiss type machines and advanced mill turn type machines. With the ability to see as much of the machine as you would like to see, or easily hide the cabinet, you can really focus on the components that you need to see. Additionally, we offer viewports that will allow us to set up multiple configurations so we can really zoom in and focus on the particular areas that we're interested in. Let's go ahead and run this simulation and you can see what I'm talking about. With the move list open, you can also watch the moves as they go by, and you can scroll back and forth to any of the different moves among the operations, giving the user the ability to make sure there are no collisions and no interferences before sending code out to the machine on the floor. All right, well, thank you. Appreciate you spending some time with us this afternoon, and come on over to booth 840 to take a look at us. We'll see you over there.